Hi, welcome to this video. My name's Phil and I'm a senior lecturer in astrophysics at the University of Lincoln, and I want to use this video to basically have a look at the brightest cluster galaxy. Now, some of you might already know what galaxies are, what clusters are, what groups are, but just in case you've come across this video kind of on its own, I'm going to kind of recap those before I actually explain what the brightest cluster galaxy is. So, just to recap on galaxies, these are vast systems of stars, gas, dust, and dark matter, and they're essentially gravitationally bound together. Some of those are more disk-like. They're like this one here is a spiral galaxy, so they're kind of like rotating, more disk-like. Some of them have different ratios of stars, gas, dust, dark matter, things like that. But generally, that's what they contain, and then they're massive systems, basically. Now, there's a few different sorts of galaxy that you can have, and this is the typical Hubble classification system, where it's like a tuning fork. On the right-hand side, you have your spiral galaxies, and on the top of that fork is your normal spirals. On the bottom is your barred spirals, which actually is what the Milky Way is. And sometimes you have one in the middle, which is the intermediate, so they don't have a very strong bar, but they don't have a kind of spherical bulge in the centre either. Now, the ones on the other side, the ellipticals, these are more spherical, they're smooth, they don't have spiral arms, and they're mostly classified by their shape, essentially. So it's how elliptical they are to how spherical they are, and it gets a number, basically. Now, there are other galaxies on this kind of classification system, but they're the key main types. There's obviously lenticulars in the middle, dwarf galaxies, irregulars, all that sort of stuff. But these are your two main types. So, if we have galaxies in the universe, they're not evenly distributed. And if we zoom out, we'll actually find the actual distribution of those galaxies on the universe, and they're not kind of evenly distributed, evenly spaced out and just dotted around here and there. What we typically find is that they kind of group together. So most galaxies are not isolated on their own in space. Some of them are in the universe, but not all of them. In fact, the vast majority of them tend to cluster into these gravitationally bound groups or clusters. And there's groups and clusters. Groups are kind of smaller, so below 50 members would be classified as a group. So that's 50 galaxies in this kind of collection. That would be a group. 50 to 1,000 members is what we would classify as a cluster. So you have a considerable amount of galaxies in this kind of high density region in the universe. And they're typically size-wise over like 1 million parsecs in size. Again, groups are typically below that, but it's clusters we're interested in here because these have the most galaxies and they have some slightly different properties to groups. So, in clusters, and this can be similar to groups as well, but clusters have more galaxies and they do have a variety of different sorts of galaxies. So they have your elliptical galaxies, your spiral galaxies, they have galaxies that are merging, irregular galaxies, dwarf galaxies. So clusters host lots of different sorts of galaxy. They're not just the same galaxy. Although, typically, to be honest, you do find certain sorts of galaxy at different locations within the cluster, but that's a whole other video entirely. So, the brightest cluster galaxies in a cluster, they're essentially going to be the brightest in the cluster. And I've got the cluster in the background there, and I've kind of highlighted maybe one of those is actually the brightest cluster galaxy in this particular cluster because they are the brightest ones. So could be one of those there. That's pretty much all it is, really. If we have a cluster of galaxies, the brightest cluster galaxy is the brightest one in that particular cluster. However, there are some key things about these particular galaxies. They're generally at the center of the cluster. So they're not kind of at the outer edge. They're typically found in the center parts of these very large clusters. Now, why might that be the case? Well, the center parts of clusters are typically higher densities of galaxies. So there's more galaxies per unit volume than there is further out. So you've got more galaxies going off their higher densities. As you get further out, the density of galaxies typically kind of drops off. Now, these center brightest cluster galaxies are generally also the most massive galaxies in the universe. So these would be like giant galaxies, the biggest ones that we have. Just as an example, this is not perfectly to scale, but we've got a bright cluster galaxy on the left, and then we've got our own Milky Way, which is actually a fairly large spiral galaxy. So you've got an elliptical galaxy on the left, spiral galaxy, and they are typically the most massive galaxies that we actually have come across in the universe, which just so happen to be the brightest in the cluster and also located in the centre of these clusters. And as I probably might have mentioned just then, they're generally elliptical galaxies. We don't typically find that they are spiral galaxies in the centre of clusters that are the brightest. It's typically your elliptical galaxies. Generally, they're bigger as well, because spiral galaxies are going to evolve kind of into ellipticals most of the time. So they're typically going to be bigger anyway. If they're bigger, they've got more stars, they're going to be emitting more light, they're going to be brighter, basically. So they're generally elliptical galaxies, not spirals. And yeah, why are they actually in the centre? Well, I mentioned that they're higher density, but in a higher density environment for these galaxies, so you've got lots of galaxies that are very close to one another compared to further out, you're going to get more interactions. So what happens there is, if they're in a denser environment in the centre, these galaxies are going to collide, they're going to merge, they're going to interact in some way or another, and they're essentially going to grow. If they collide, you end up with a galaxy that's bigger than the initial two galaxies that kind of came together. And actually, galaxies don't just collide in pairs, they can collide in groups and much bigger kind of mergers as well. But here you've got two galaxies that are merging, two spiral galaxies that are kind of distorting one another gravitationally, and they will basically, their final galaxy that they will then become will be much bigger than the individuals that came together first. So generally, we kind of assume that smaller galaxies, smaller kind of dwarf galaxies, spiral disk-like galaxies over time merge, they grow bigger, and then eventually they then become these elliptical galaxies. Now, you can get elliptical galaxies without the mergers in these isolated systems, but that's another route entirely. But if you've got an environment where you've got lots of galaxies merging, colliding, then over time you're going to get a much bigger galaxy at the end. And in the centre parts of clusters where there's more galaxies per unit volume, this is going to occur more often. So you're more likely going to end up with a bigger galaxy at the centre than anywhere else in these particular clusters. So thank you for watching. If you enjoy the videos and find them helpful, then do consider becoming a member. There's extra videos in the members section, but it also helps support the channel as well. So thank you for watching.